Hello, in this video we will discuss about some of the common reactions that alcohol undergo, and alcohol are the compounds with OH as the functional group, and since this compound possesses this active OH functional group, they can undergo varieties of reactions, and some of these reactions we will be discussing in this one. Among these, one most common reactions of number one, the most common reactions of alcohol we call the oxidation reaction. Here, first of all, in organic chemistry, we still like the classical definition for the of the oxidation. So whenever we say oxidation, we consider that as the addition of oxygen. Addition of oxygen, or in other words, since oxygen and hydrogen have opposite role, we also consider oxidation as the removal of hydrogen or addition of oxygen. That is what we call oxidation. In electronic concept, the oxidation means the loss of electron. Like in modern concept, loss of electron we consider as the oxidation. So here the alcohols are well known to undergo oxidation reactions, and we will discuss first about some of the oxidation reaction of alcohol. Now, as we know that alcohols are three types, right? If we have, and the product of the oxidation depends upon the type of alcohol under consideration. Okay, if we are using, say for example, primary alcohol, 1 degree alcohol, upon oxidation, this there will be the loss of hydrogen. For example, these two hydrogen will be lost and it will be converted into aldehyde first. But under oxidation condition, sometimes the alcohol will be still reactive and can undergo further reaction. It will undergo further oxidation to give the carboxylic acid. Carboxylic acid. So depending upon the type of the oxidizing agent we use, the primary alcohol either will convert into aldehyde, or if the oxidizing agent is strong enough, it will further oxidize to carboxylic acid. And we will be giving some example related to that. Now, if we use secondary alcohol means the carbon that has the OH group will contain only one hydrogen or two R group, secondary alcohol, which upon oxidation, if we do the oxidation, then it will lose these two hydrogen, and since you have two R group already there, this will be converting into ketone. So secondary alcohol in any type of oxidizing agent will convert into a ketone. Whereas if we take tertiary alcohol like say R, C, R, and OH, now there is no uh, other hydrogen to be lost in this case. So if you oxidize this one without breaking the carbon bond, there will be no oxidation occur. So no oxidation happens for the tertiary alcohol. So tertiary alcohol do not undergo any oxidation reaction unless we break the carbon bond there. Okay, so this is the tentative idea. Let us try to discuss them with the examples. What are the oxidizing agents that we will be using, and how? Let us discuss with some examples. Say for example, for the oxidation reaction of the primary alcohol. For primary alcohol, as we said that if we use in presence of strong oxidizing agent, if we use a strong oxidizing agent, and now strong oxidizing, very common strong oxidizing agent involved, like say sodium dichromate in presence of sulfuric acid. So or even you can use chromic oxide in presence of acid, or simply you can say chromic acid, or even potassium permanganate KMnO4. These are some example of strong oxidizing agent. This chromic acid reagent in fact will result in the formation of chromic acid, that is a strong oxidizing agent, or potassium permanganate. Okay, in under such condition, the primary alcohol with strong oxidizing agent will convert ultimately into uh, carboxylic acid. Carboxylic acid, as we discussed earlier, it will undergo carboxylic acid. It will not stop in the aldehyde stage. It will be further oxidized because these are the strong oxidizing agent. Okay, so for example, if say this alcohol here is a 1-propanol, for example, 1-propanol, and it is a primary alcohol, as you can see that. So if we oxidize this by using any of these strong oxidizing agent, say for example Na2Cr2O7 in sulfuric acid, or you can use even potassium dichromate. Okay, this is sodium dichromate in sulfuric acid, or you can use potassium dichromate in sulfuric acid, and or any other, then it will undergo the oxidation to give carboxylic acid. So this is propanol. Okay, 1-propanol, 1-propanol, it will go to carboxylic acid, C double bond O OH. Okay, this is 3 carbon with OH, 3 carbon will be with carboxylic acid. So it is 1-propanoic acid, or simply propanoic acid. Propanoic acid, or it is carboxylic acid. So primary alcohol is oxidized to carboxylic acid. And now, just in case, if we wanted to uh, stop this reaction to the aldehyde, right? If we wanted to, okay, let's give some other example. Number B, if we use like a secondary alcohol, say for example here 2-propanol. This is number B for the secondary alcohol, and use again this strong oxidizing agent, right? Any you can say again sodium dichromate in sulfuric acid, or any other oxidizing agent. So this will be converting into a ketone. Okay, whereas if you have the tertiary alcohol, that will not be oxidized. As we said earlier, if you have this kind of tertiary alcohol, you use sodium dichromate and sulfuric acid, you can say it will not undergo or no oxidation occur. So, but if we use the under mild oxidizing agent, if we use mild oxidizing agent, some very common mild oxidizing agent that you need to be familiar with is one is PCC, that is called the full form is pyridinium chlorochromate. Pyridinium P chlorochromate, that is what we call PCC, and the structure is pyridine is like a 6-member ring with one of the member as nitrogen. This is called pyridine. And now pyridinium, that is when you have the nitrogen with the with the hydrogen. So this is your pyridinium, and that will have chromate and chloro. This is what we call pyridinium chlorochromate, okay, or PCC, pyridinium chlorochromate. Pyridine, and whenever you have hydrogen, is called pyridinium, and chlorochromate, that is what we call PCC. And this is a mild oxidizing agent. And in presence of mild oxidizing agent, if we take primary alcohol, 1 degree alcohol, then it will, with the PCC, it will stop in aldehyde state. It doesn't undergo the carboxylic acid, it will stop in the aldehyde state. So if from the primary alcohol you wanted to stop the reaction in um, aldehyde state, then we need to use the mild oxidizing agent, or PCC. So pyridinium chlorochromate. So remember that it's a mild oxidizing agent. There is other way of stopping in the aldehyde state. That is what we call Swain oxidizing agent. Swain oxidation. Swain oxidation. And in this case, the reagent that we need to memorize here is, one is DMSO, dimethyl sulfoxide, DMSO, and in presence of oxalyl chloride, or a C double bond O, C double bond O Cl, that is what we call oxalyl chloride. Oxalyl chloride, which you can even write as COCl whole 2. The extended structure we can write like this or this way. This is the shortcut. DMSO, you are familiar with that. DMSO in presence of oxalyl chloride, and the base triethylamine is used. This is what we call the reagent for Swain oxidation. Okay, this also will do the same job as the PCC does. The primary alcohol, 1 degree alcohol, in presence of uh, this oxidizing agent will convert into aldehyde. So that will stop into the aldehyde. So this is the Swain oxidation. What are the reagent here again? We use DMSO, dimethyl sulfoxide, and oxalyl COCl whole 2. And ET3N is the base that we use. That is what we call Swain oxidation. And one beauty of the Swain oxidation is that all the side product that comes with this one will be like a sulfur dioxide or carbon dioxide. All side product will be very easily removed as the gases. Therefore, Swain oxidation has some advantage for the workup. So it is an important one. And as we discussed already, then if it is the tertiary alcohol, there is no oxidation occur, that we have explained previously also. And one more point to be noted, if the secondary alcohol, either we use the strong oxidizing agent or even with the mild oxidizing agent. Mild oxidizing agent like PCC, Swain, all will convert that into ketone. Secondary alcohol always give ketone. Either we use strong or mild oxidizing agent, where tertiary alcohol, no oxidation takes place. So these are some oxidation reaction that happens in alcohol. All right. So in your test, you may have the questions, okay, we have this alcohol. Now we are we are using like Na2Cr2O7 and H2SO4. So what is the product? So what you need to know is, first of all, you need to decide what type of alcohol is this. So in this case, you have your 2R group here and OH, and there is one hydrogen. So this is your secondary alcohol. So any type of oxidizing agent will convert that into a ketone. So the result